Are we live? I think we're live. Hello. Welcome, everyone, to Sunkworks, episode 41. I want to start with a song. I always start with a song, kick things off. This one's a little slow, a little mellow. Hope you enjoy it. It's by Ren. Let's cut to the song here. Try to work on my transitions here. Go from talking about the song to we're going to focus on the song, but I've got to make sure that the audio channels are right before we go, or we're going to have to start over. Okay. That was great. All right, so we've got another little mini series going on here. We're moving back, I think, towards soon we'll be able to finish the How Hard Can It Be series. How hard can it be? I just want to publish my website, right? That's the premise anyway. So we've decided that we want to do it on the cheap, and we want to do it using the latest and greatest serverless technology. We want to use WebAssembly. Okay, so we're using Spin from Fermyon, which is really cool. Really cool here. And we've got Flux OCI repository pattern here that we haven't quite figured out how to name yet. I think I'm calling it in some places the app pattern, in other places the config repo pattern, but we've already used the config repo pattern for something that's a little bit different. Why don't we talk about the 3 different kinds of repos in Flux terms? So there's your bootstrap repo, which must exist, and I'm saying must exist because it's in the docs. So it is the prescribed way to install Flux. So if you're doing something else, and this means you too, managed service vendors, if you're doing something else, if you're managing Flux on behalf of someone, all bets are off, because that person, if they need to configure Flux, they will not have a bootstrap repo of their own to configure Flux with. So you will need to provide them with an alternative interface for configuring Flux if they should need to configure Flux in ways that are above and beyond what's supported by the CRD. Okay, so our Flux deployment is really simple. We've got a directory called deploy, and you'll see this in many Kubernetes projects. It's not always called deploy. Sometimes it's called manifests. Could be called anything you want. It doesn't really matter what it's called. We've got 2 customizations that apply things in order. So there's the app and the infra. This infra always goes before app. That's the pattern. Well, that's one of the Flux patterns that you need to understand here. So the other parts here are not appliers. They don't apply anything. The OCI repository pulls in the source and verifies it. Right? It does it from this OCI repo URL, which happens to be public. They need not always be public. And it points at a tag, ref tag latest here. So this latest tag is akin to a branch. The latest tag is, in this repo, always populated from the main branch. So when you push a commit to the main branch, or when you merge your PR to the main branch, this workflow executes. That creates first a build, right? And then if any tests are needed, you would have your tests here after the build is done. Of course, we just have a build because it's a simple website, so there's nothing for us to test. Maybe there could be tests. We'll leave that alone for now. Then we install Spin, which is used to pack the output. And we've done a little munging on this output. You can't see it here, but in the workflow file you can see we're deleting a bunch of stuff pretty much arbitrarily because if we don't, if we have too many things, well, we'll see. This still only sort of works, is what I'm going to tell you. But we will be able to see actually today. This is the good news. We will be able to see this works. I mean, it works. We're serving the web page now. So we've been able to do that with Fermion Cloud. It hasn't been a problem. We've been able to use Spin Up really productively. So we're already satisfied Spin Up customers, but we want to move this onto Kubernetes because we've been using Kubernetes, and we don't want another second system here, right? We want to use Kubernetes. We don't want to use bare metal. We don't want to use a vendor API that's outside of Kubernetes, right? If anything, we want to manage it with something inside Kubernetes if we have to use one of those APIs. But we ideally would just like to use Kubernetes because it's a hosted solution and we could just host it on Kubernetes. We're already paying for that infrastructure, so we might as well. So we install Spin and we push using this command that we had commented out last time you saw me. We replaced it with a Docker build instead because we thought that would fix things. It didn't fix anything. It didn't actually change our error code 137 a single bit. So we went and talked to the devs to see if we could get some help to figure out what was wrong, and they did point us at a different issue. So we'll see in this commit, actually, I think we can see. We go back to the PR. Is there a backlink to the PR, maybe? I really thought there would be one on this page. All right. Sorry, I've lost track of what we're doing. Okay, so this didn't fix a thing. We removed the deploy to Fermion Cloud step because now we've got a deployment that works, sort of. Then we set up the Flux CLI. Okay, because we're not just deploying a WASM. We've actually got some declarative configuration that is part of the deployment. And understanding that the configuration is part of the deployment is the thing, I think, that takes it over the line to where you start to understand, hopefully, what Flux's OCI repository feature is for, and what it gets us above and beyond simple GitHub Actions workflows, or just simple GitOps without the workflow at all. So we're able to sign our manifests, which may not be a big deal for everyone, but we've got some modifications. So even if we were to take the Git repository source and compare it against the manifest that we're going to deploy, we would see some things are a little bit different here, right? So we've got this set image, looks for an image reference that says Flux docs build, and it sets it to this new image that we're building. Actually, it's the image for our repository, not any old Flux docs repository, with a tag that is a numeric tag. And it's not important that the tag is numeric because it's embedded here in the manifest that we're going to deploy. So this is done by the release workflow, right? Because this is a trunk-based development style. So we release straight from the main branch. When we make a change in the main branch, it's immediately built and pushed out to our deployment. And that is done by Flux here, push manifest. So like we said, we have our Flux docs build repository. We also have a Flux docs manifest repository that takes a couple of arguments, and we sign that as well. So earlier we signed our well, we haven't signed anything yet. Okay, we sign our YAML manifest, we sign our WASM artifact in case someone is going to verify it down the line. I don't know if there's anything that does that yet. All right, and this works. It actually works. We can see we have some running pods here. We're going to kick them over, and we're going to see how quickly this works and how nice this is. So let me find my deployment here. We got to make this font a little bigger for you. We're going to make some change. Oh, we don't need to make a trivial change, right? We figured this out last episode. We actually have dispatch here, so we can run workflow using workflow dispatch. All right, so we're just going to trigger a build, which is going to trigger then downstream a deployment, and we're just going to watch how this works, see how much we can observe. We're actually going to get the VS Code extension out too. Oh man. Right, so the build is quick, so we got to be quick or we're going to miss it. Here's our OCI repository, and here are our two workloads. We see things are spinning All right, we've got the build is done. So once the push to OCI, this is not Flux push, this is Spin registry push. Once that's done, we're still not ready to deploy yet. We've got to cook up our manifests and push them and then sign them. And so we'll see really briefly as the pushed manifests hit the OCI repository and Flux finds out about them thanks to the receiver. We'll find out about them right away. It will check for a signature and it will find none. And there it is, verification error. Then the signature arrives. Now it's ready to deploy. So it goes to infra, deploys infra, and then app deploys. And we see we're already done. And if we go back here, we can see we've now got 2 new pods. And we're already done. So that's a great experience. That's great. And if our build wasn't so long, let's see what takes the longest in our build step here. It's definitely not signing. Look at these things are all 1 second, 2 second. Maybe installing these tools takes a few seconds. No, cosign doesn't take a whole second to install. Set image, no, none of this stuff does. Set up Flux CLI. Install spin takes 2 seconds. Okay, push to OCI, so that's actually takes 5 seconds because this is a rather large artifact. And the build itself takes, I'm gonna guess it's gonna take like a whole minute, right? Is that how long? 45 seconds. Yeah, so everything set up, all these things look like they're here. We've got a second git clone that happens because that's part of our build. But right, the bulk of the time is spent on the build. So we expect this to take about 45 seconds plus some change. And that's just what it takes. So we can do this demo multiple times in a lightning talk if we were to have a lightning talk set up for this, where we could just kick off the build before we even start talking so people can see as we talk about whatever it is that we don't have much time to talk about because the build will be over within less than a minute and it'll be deployed and it will be done. I have to think about how to present this. But the VS Code extension definitely helps. The other thing I think might help is if we added, I think we should add a semver tag here. So this would be the staging environment where we don't necessarily need to verify signature. And then we could have a second environment, a production environment, where we actually only deploy from tags. So if you want your build to be released, you have to tag it. And the tags could, I'm not sure how this is going to work exactly, but we want to do a little bit better. One thing we're not doing is we just plug that build number in. We just plug a tag number in, right? So we can't take advantage of service like ttl.sh, where if we push this build to ttl.sh, we don't have to authenticate or anything, and we can just come back and refer to it by the SHA, the digest, and it's fine, and there's no issue. Right, we would normally be very apprehensive about something like an unauthenticated registry, but the digests all can be verified by the client, and so you don't actually have to trust anything about it. You just have to trust that hash algorithms actually work and that they don't have collisions. So that's pretty cool. All right, so let's see. We got off to a quick start now. Let's see, what else are we supposed to show hash here? Algorithms. We've gotten to see the thing that didn't work. Oh, we wanted to talk about why it didn't work. Okay. So, bottom line, if you take a look at this directory, it normally has way more than 188 files. It normally has like 2,000 files. And if you go back in the history here of builds, you can see that some of these commits have been built and failed. And the ones that failed, here, let's see, try build again. Try to get it a little lower. What am I changing here? Well, we got this error. That's what we got. When we realized, let's back up. Spin issue number 28 here. Support archive layers. So this is what we found. We were pointed at this. We didn't find it ourselves. But if you have, so we did examine the spin, unpack the artifacts here, and we looked at it to see what shape is the artifact in. And I think the thing that we didn't pay very close attention to was in the manifest that there's a change when you have more or fewer or a greater number of files in your spin app, because there's a limit to the number of layers that you can have, and normally it likes to put each file in its own layer, which makes good sense because most of the files probably aren't changing all the time. So we can hash the layers, we can push most of the files, and then never have to push them again until they change. We can just check if the hash has already been pushed. We find that the hash is already pushed, and we are saved from having to push them again. So this is a huge optimization, except that when you have so many files, checking all these hashes probably takes a lot of compute. And wouldn't it be better if we just bundle up all the files that don't change and push them together? So that's where I think this issue is a little bit complicated to solve, because we don't. How do we know how to? Like this is the Webpack problem. How do we know what bundles? We need someone to intelligently design the bundles to say these are the assets that are unlikely to change except as a group, or like is there even a way to manage that? It seems like almost like a blockchain problem. We need to find a way where we can push all the assets individually, then hash them as a group, and then bisect the group. If we find that the group is not hashing to the same hash anymore, just bisect the group. But also, if it turns out that most of our files change on a regular basis, then we'll be doing a lot of hash work that is probably not required all the time, or a lot of comparisons, at least, that are not required. If we know we can just push the file again, bandwidth is cheaper than CPU, then I don't know which is cheaper, but that's how you think about these optimization problems at the really far end of the extremes. Is to think, well, can we just throw more whatever it is at it and make the problem smaller that way? And that's exactly what we want to do. So they bundle everything up into a tar file when it's over a particular size, and just push a single tar file. And it turns out that those layers are different, and that we need to unpack them in order to use them, and that the spin doesn't just do that. SpinKube container dshim doesn't just do that. So I'm not sure how this thing really works. I think I need to start looking at the source code to understand what does it actually do. But for now, I don't have to. I know that this is an issue, and I know that I can make my files. I can just remove a bunch of files and make this thing smaller, so we can see what happens if we don't remove as many files. I'm just going to take like this stuff and comment this out. Oops. We're going to break the build real quick. And it is actually going to succeed at building, I think. Well, we'll see. It may fail on the build, and I think it will fail on the build, actually, because that's what I experienced before. And this is the error that we'll get. Too many requests. So I think that this is GitHub responding to this strategy for us to try to save bandwidth through hashing and comparing. Because I think it is actually bandwidth that turns out to be the more expensive thing than CPU. And maybe it's because we can get access to so much bandwidth so easily that as they price bandwidth in a way that seems very reasonable, until you actually look at how much bandwidth you use, you find out, hey, that's going to cost me a lot of money, and maybe this isn't such a good idea. Maybe we should try to use less bandwidth. So I think that's what these hashing, yeah. So here's the same error. We get the same error. So there's really a little bit more to it than what this says, because greater than 500 it will result in a build that fails to run. You'll get an image out, but when you try to run it in the spin shim, you will wind up with crash loop back off, exit code 137. But if you try to push less than 500, and GitHub sees each of those layers that you're pushing as part of a attack, I guess. It says, wait, why are you pushing so many layers? Can you try to do that a little bit less? So when we push close to 500 layers all at once, we actually get this error. So we don't want to do that. So we've got to make our website smaller. And we might actually need to break our website into smaller pieces. And that might be the way that we solve this, is to just make different WASMs. You know, that might be a good solution here. Let me think about this. We push a bunch of WASMs. We still need to pack them together in an OCI, but we'll have. Well, let me think about this. Yeah, I bet there's something that we can do so that we don't have to. We want to see the actual website, right? Let's get that tail scale going here, so we can hit it on the cluster IP. We haven't got an ingress controller yet. I actually think we're going to do a short stream today. I don't think we're going to tear the cluster down and stand it back up again, because I don't have a whole hour, and I don't know if I can do it any quicker than that. Did we forget to push here? Yeah. So we should be able to see everything here. I could learn how to use tabs. Oh, look at this. That's there. I would really like to know why OBS doesn't always pick up the windows in the order that I see them. I'll look over at my OBS preview and I'll see that some window is on top of the window that I'm looking at. And I can't even see in the stream the window that I'm talking about. But so if we can break these apart into smaller VFS bundles, I'm not sure. I'm really not sure how that works. I know that we did this for Ruby earlier. Here we go. We're deployed already. All right. There. And it's already booted. Super. And I don't know if that's because most of the layers don't have to fetch again. Really, almost all the layers, because we haven't changed anything in substance. But look how quick that is. That's great. We should definitely go on the Fermion stream. I heard that they're looking to do something with Flux, and I would really like to have more good Flux material out there in the year 2024. I know that lots of people are. Well, I haven't given any conference talks this year, so I'm looking forward to going on a stream. I don't know when we're going to do that yet, but yeah. So cool. All right. So what did we say? We may also tear down our cluster and rebootstrap one more time. Yeah, I don't think we're going to do that today. But oh, did we actually forget again? Before we, yeah, here we go. So we've dumped all the images out, so there's no images. There's also no blog, and a lot of the documentation has been gutted out because there's just too much. So maybe if we pack all the images into an image bundle and only deploy the image bundle when the image bundle changes, that would be reasonable. Like each of those things that I'm removing, say they're too big. I think what we actually have to do is just wait for the Fermion folks to. Well, I hate to say just wait. I mean, maybe we can help them build it to go and solve the layer solution. But I'm not. I'm grappling with how can that be solved well. Um, I feel like there's a reason why they haven't already solved it, right? Because it's actually a difficult problem, and you want to be able to accept hints. But how do you make an interface for that? How do you know which assets to group together? In Webpack, you count on the developer to make packs and then to include them where they're needed only, and that way, right, you can send just the assets that are needed down to the client and not the ones that they won't call. But that sort of tree shaking requires a lot of heavy lifting in order to be able to do it safely. So I don't know. But we are able to serve the web page from inside of a Kubernetes cluster, at least in some limited sense. Right, it's missing all of the Flagger stuff. Well, we don't even, that's something, huh? Yeah. I didn't realize that we don't link to our own local Flagger. Ooh, that's ugly. Why is it that way? They did a lovely job on this, but there are a few rough edges that still need to be sanded down. This is a new feature on the web page. If you want to see only things from a particular year or only articles, you can see we actually don't have any articles. It's all videos. We added this feature, articles, so that we could link to other outside resources, and I feel like someone has to do this now and do the job of collecting all the articles about Flux. But I only want to read technical articles. I don't want to read another article about Flux's survival, or maybe I'm alone in this. It's really grating for me to constantly hear about our death and survival. It's I guess there are worse things than surviving, but all right. So this works, and we're going to look at the resources one more time in the deployed tree here, because there are not very many. Just for completeness. This skips over the actual installation of Spin, which we covered last week, I think. But we do need to create a Spin app executor, which is something that lives in the namespace with our Spin app. And it tells Spin, I guess, I'm not sure what these knobs are for. Create deployment. I'm assuming that you need the deployment. Maybe there's a reason to not create the deployment. And then we've got our customization and images config. Oh. Sorry, I'm reading Spin app and I'm typing Spin infra. So in our Spin app, we actually have an images config or a config, customize config, and we've got a Spin app. So here we've got our simple customization, just invokes this one resource. This is our infra, okay? And then our app has a configuration that explains what to do with this images. It's customization. Because customize doesn't actually know what to do with this image value. So we're going to overwrite this value in CI. It's going to get our new image name and tag. But customize doesn't know what to do with this when this resource is a Spin app. So we tell it, it's spec.image. This is really easy, but if you don't know how it works, it's not easy. If you've never done it before, if you don't know that it's even a feature that you can use. I had to look it up. I kind of said, well, there must be, because I'm reaching for it. And I was very lucky because I reached for it and I just found it there. So this image gets updated, and then all of our Flux OCI stuff. Here's our customization for our Spin app that depends on docs infra. So one is called docs app and the other is called docs infra, right? Because we might have a bunch of Spin apps on our cluster. This one is for the docs, the Flux docs. But we know that. We don't need to say Flux docs everywhere. And this is for the thing that needs to happen before. So it doesn't say depends on anywhere because it just happens before the other one. As soon as it gets applied, that's fine. It doesn't need to be told to wait for the bootstrap to be done because this won't be applied before bootstrap. There's no dependency there. I see people sometimes set up a link of depends on that goes all the way to the top, and that's fine if you know that you need that. There are some circumstances where you need that. Like if you have Caverno, you really want to be sure that your Caverno policies are up to date before anything else happens. But we're not doing any of that. We've got our OCI repository. We already saw this. We saw how the verification is done against the GitHub token. We could make this more specific if we wanted to have a separate OCI repository for production, which we might have to do, right? Because this ref here can only point at a single ref. And if we want production to be tag-based, we're going to need to make this something like 1.x here. So we're not going to do that right now. And then we've got our receiver, which we've got another receiver set up for the Bootstrap repo, so that whenever we push a change to the Bootstrap repo, or whenever a new version of our OCI repository is published, it gets notification immediately on the cluster. It begins to reconcile, and it's ready to go as soon as it possibly can, with no intervention. And this is super important, because if you don't have this, you're going to have a frustrating experience of waiting and wondering what order they're going to be applied in if you ever have multiple sources, where really what you want is for them to be applied in the order that the changes arrive, not in some other order, usually, right? And then we've just got our simple customization.yaml. So that's all the cool stuff. And I'm going to try to figure out how to present this for a bigger audience, because I don't want to look like a schlemiel. But we've already done that, right? We've done that a couple times now, so I don't think that I have to do that again. Done that at least 40 times, because we've had 40 episodes of Sunkworks so far, and something always breaks, even when it's my birthday. Okay, so thanks for checking this out with me. I would really like to tear the cluster down and create it again. Maybe we'll put some music on and just do it. I don't know. Really short episode today if we don't do something else. No, I think we've done what we set out to do. We're going to listen to one more song, though. I'm not sure what song, but we're going to find one real quick here to carry us out, because I love music, and I know you do too. What music are we going to listen to? This is another good song. We're going to listen to that one. I like it. All right, so if I go to... Sorry, I'm going to check my audio inputs here. Make sure that we've got everything right. Here's my OBS. I'm really curious about this never going to give you up fugue, but I'm not going to click on it. I have more respect for you than that. Okay. Yeah. I just have to turn off my mic and play the music. See you next time.
Don't feel safe in this bed. There are voices in my head. I've been talking to the dead, and the fear baptized me. My kingdom turned to dust, and I watched all my riches rust. Have I lost the Midas touch, or do sad eyes blind me? Over and over we go, over the hills and the valleys below. Oh, and it follows me home, and it suffocates me. No, I can't breathe. I said, oh, I can't breathe. All I know is I forgot how to be me. Ooh. feel safe in these halls. There are bruises on the walls. There are bodies in the floors, and they breathe so loudly. I wish I could move, get up and walk right out this tomb. Do our saviors die too soon? For my sins surround me. Over and over we go, over the hills and the valleys below. Oh, and it follows me, follows me, follows me, and it suffocates me. I can't breathe. I said, oh, I can't breathe. All I know is I forgot how to be me. Hallelujah. Where is my God? Where are you? Hallelujah. Nothing is pulling me through. Hallelujah. When I don't know how to be. Hallelujah. I forgot how to be me. When he gave up the fight, a quick decision late in the night that stayed with me for all of my life. I miss you so.